Not sharing. Okay. So can everyone see my screen?
Yes.
Okay, good. So tonight we're going to talk about the final two modules or the challenges in Codio, which are file handling and regular expressions, and we will also talk about the regular expression draft milestone. So I'm just going to go right into it. If anybody has any questions, just let me know as we go along. And if there's after I'm done, if there's anything that you have questions about previous assignments, about any of the drafts that you've turned in, or have questions about how to fix errors, let me know. And just to let you know, we will do another conference call next week just to go over any questions you have associated with the milestones as well, any milestones that haven't been turned in. So, hello. What we're going to start talking about tonight are files. So up to this point in Python, what we have done is all about just data that sits within the program itself, nothing external. So when we did the TM script, the $500.25 was set as a variable. But that doesn't do anybody any good. In the real world, you have to store your data in some form of persistent storage off on the disk. So it's not just in the memory, the running memory of the program. It's actually in a file somewhere. And so this module is an introduction into how to read and write files in Python. So there are four things you can do with a file. You can create, you can read it, you can update it, and you can delete it. So you can create it, which is just that. You create the file, brand new, it's never been on the disk before. You read it, which means you read in data from the file, either in part or in whole. You update it. And update can be adding new data to the file. It can be removing data from the file. And then you can delete the file, which means you can remove it from the file system. But basically, everything we do is in files. This is just the experiment section. Everything we do is in files, okay? And your Word documents are files, your Python is files. Everything is about files when it comes to computers, so we have to understand how to create and manage them. And section 2 on this is just talking about the different paths that you can, because MS-DOS has a path that looks one way, and Linux-type systems have a path that looks a different way, and HTTP URLs for the web look a different way. So there are all kinds of paths. The important part is that every file has a path. So it has basically a trail of breadcrumbs where it sits on a disk. And what we consider those when we're using our computer is it's in a folder, okay? So most files sit in a folder somewhere on the disk, whether that folder be directly under the drive or whether it be in my documents or whether it be someplace else. So when a file sits in a folder, it will have a path. So that's all it is. And the importance of the path is that, the program won't know where your file is by just its name. You're going to have to tell it exactly where it is by giving it a path, okay? And sometimes that's called a fully qualified name, but that's how you tell Python about the file. If Python can't find the file, in your program, it's because it doesn't know the right path. Either the file name itself is wrong or the path is wrong. So here's just a quick introduction to what they're calling file descriptors. So a file descriptor is the way in which you access a file on any computer system, okay? And a file descriptor is basically just it's just a variable that holds information about the file. It doesn't hold the file itself. It doesn't hold the data in the file. It holds the information about the file. It will hold the name of the file. It will hold the path of the file. You can use the file descriptor to find the size of the file. And most importantly, you can use the file descriptor to manage when the file is open and when the file is closed. So over here on the left-hand side, we have just some examples. So file A is just a variable. Okay, that's all file A is. It's right here. It's just the name of the variable like any other variable we've had. What's special about this is we're going to use the Python function called open. And open is specifically a Python thing, and it says, I'm about to open a file. I'm going to give you an argument. That argument is going to be a path to a file, and then I'm going to open that file, and I'm going to do something with it. Well, the thing that I'm going to do with it is read or write. In this case, it's an R. Sorry about those. I don't know why they're coming up. In this case, it's an R, so we're going to read. Okay? So reading just means I'm going to bring data in from the file. It's like opening up a Word document and you reading through the Word document but not having the ability to edit that document. So it's one of those like read-only documents you can get in an email or something. So that's what the R does. So open tells Python, I'm going to open a file. It takes two arguments. It takes the fully qualified path to the file, which means the entire path plus the file name. And it takes the argument of what you're going to do to that file. So in this case, path A is path A. And path A says, I'm going to open up a file called called parrot.txt. And parrot.txt sets in the content folder and a text files folder. So text files is under content. This is a fully qualified path to the parrot.txt file. But it's all here in one string. So I'm going to open that file. File B is a variable that's going to end up being an opened empty.txt file. Now you can get the file descriptor by just doing .fileNo. And you in this class won't really use file descriptors a lot. They wanted you to know about them. What I care about you knowing is opening and closing a file and what you're doing with that file when you open and close it. Opening opens it from the disk. That's disk I/O. The most expensive thing you can do in computer programming is disk I/O. So reading or writing from a disk. And that's true whether you're writing in C or Python or Java. All the same. So open reads it from a disk. Close says, okay, I don't need this file open anymore. I'm going to close it. And you have to close all of your files. Why? Because of this file descriptor thing. file descriptors are limited on all computer systems. There's only so many of them. And every time you open a file, you create a file descriptor. Every time you close it, you give that file descriptor back to your system. If you continue to open files without closing them, you will use up all your file descriptors and you won't be able to open any more files. So for every open you do, you need to make sure you close when you're done with the file. So we can just run the sample here real quick, and we just see the output. File descriptor A, file descriptor B. That closed it. So opening a file. Here we already talked about file A. Oops. File A variable, we're doing open. We're giving it the path and what we're going to do. So you can open a file for reading or you can open a file for writing. So that's pretty much that one. Closing a file. You just use the close function, the variable, the close function. Python will know that you can use the close function on file A because you opened it and it gave you back the file. So it's very simple. Just remember to close it. Okay, so there are a couple different types of files. There's text files and binary files. In this class, we're only really going to care about text files. And really the difference is one is human readable and one isn't. If you open up a Word document in a text editor, you won't be able to read that Word document if you just, in a Linux command prompt, opened it. It's not human readable. It's got weird characters in it, and it's because Word interprets that information to show you what you have on the screen. What we're going to care about in this class is text files, not binary files. Binary files, you have to do some translation, and we're not going to worry about that. So there are more than two types. So there are lots of types of text encoding. And why do we care about text encoding? Well, because what you can do with a text file can be a lot or a little depending on the text encoding. So if you look at ASCII, ASCII is the most restrictive. It's the oldest text encoding, and basically you have 128 characters. That's it. So, and that includes your uppercase, your lowercase, all those extra characters on the keyboard, the percent, the ampersand, the and, the star. All of those have to fit into the 127 characters, plus non-visible characters, like a new line or a bell ring or things like that. So it's very restrictive. So you can't do a whole lot. This is ASCII was basically the first encoding system for text, and it was great and wonderful, but it's extremely restrictive. You have ISO, and the next standard was an ISO standard, and it's a little less restrictive, but not much. You really get into non-restrictive when you get into UTF-8. UTF-8 is Universal Code Character Set, basically, and UTF-8 allows you to have all of the ASCII stuff, so it's completely backward compatible, but you have so many more characters. When you, it's much more freedom, and most of the things we do today are UTF-8 encoded. And this is just a little table that talks about the encoding. So you can have in binary, you have this long number, that's it as a decimal. ASCII, it's these weird characters, and UTF-8, you have a copyright symbol. So UTF-8 um, is the least restrictive, and it's what's pretty much used today. So don't worry about any of this. What we're going to be working with are simple text files. Okay? So reading a text file. Once you open it, you don't have the data yet. You just have the file. You just have that file descriptor. Well, how do I read data from the file? Well, it's very simple. You use the read function. Okay? So I have opened the file. You always have to open first. This is very stepwise. Open, read or write, and close. And they didn't close it here, which makes me very unhappy. File 1 dot close. So if I run this, what will happen? Well, very simple. I have this file path to the parrot.txt file. So it's parrot.txt, sits in the text file folder, which sits in the contents folder under my Codio area. I have file 1. I'm going to open this file, defined by file path for reading, which means I can't change anything. When you see this R here, it means you cannot change anything. I'm going to read the data in from the file. So now I've brought it from the disk into my program. And that's very important because you can't do anything until you read the data in. In this case, I'm just going to print the data out, and I'm going to close the file. Okay. So reading a text file. So you're going to be passed the file with path P and a string S on the command line. Output the number of times string S appears in file P. So what do we have to do first? Okay, we always have to open the file. Second, we have to read in the file. Now, if you'll notice here in the challenge, it didn't say anything about changing it. So we're going to open the file for reading only. And then when we're done, we're going to search the data for a character. And then finally, we're going to close the file. Okay? So that's going to be the flow of our program. So first, I want to say file is open. And they're telling me here that you will be passed a file path P. So I know that it's going to be P. And I'm going to want to open it for reading. Whoops, for reading. And then I want to read in the file. So data equals file.read. And then I want to search the data for a for the character S and see how many times it's there. And we'll do that in just a second. So then I'm going to close the file. Okay? So I'm just going to check and make sure I don't have any syntax errors, and I don't. So that's good. So now, how do we count the number of characters in a file? Okay. Oh, sorry. Count the number of Okay. So count the number of occurrences of a character in a string. And here we have it. We have sentence.count A. So in our string, all we have to do is use the count method. It was just very easy for me to come out here to the web and ask the question. Wonderful thing about Google is it'll always give you some kind of an answer. So here we have data. Now we know right now, or maybe we don't know, maybe I need to tell you, this read function always turns a string. When you get it back, it's going to be a string. If you want to do anything else with it, you're going to have to change it from a string. So we know, because we used read, that data is going to be a string. So I'm going to be able to say print data dot count s. Check it. And there we have it. Okay? We counted parrot, the word parrot. It showed up 3 times in our file. Does anybody have any questions about this?
Nope, no questions.
Okay, good. So, rating a text file. So far we've only read. We've only read things from disk. Well, now it doesn't do me a whole lot of good because I want to be able to read and write. So I want to be able to read in things. I want to be able to change them. I want to be able to write them out. So I can open a file for writing with the W. Same method, open, same first argument, fully qualified path, but I want to write to this file, which means I want to change it. So I open the file, and when I want to write it, I use the write function, and I will write out to the file, and then I will close it. The close here is really, really, really important, and that's because until you close it, there is no guarantee that your data is actually written to disk. So if you don't close after you're finished writing to the file, the data that you're putting in that file may or may not be there. You don't know. It all depends on what the system and Python are talking about. So close is extremely important here. It's not just about using up a limited system resource. It's actually about your data integrity. So what I'm doing in this program is I've got file 1. I've written some text to file 1, and then I've closed it to ensure that it's written to disk. And then I'm going to open for reading, and I'm going to print it, and I'm going to close. And then I'm going to open it for writing again, and I'm going to write something out, and then I'm going to open it for reading again. And they should have closed it. Drives me nuts that they don't do that. So if I run the sample, basically this is what I got output. I knew I got better. But the important part here is we understand that to write to a file, you have to open it for writing. So you have to have W as the second parameter of the open function. To actually put something into that file, you have to use the write function, and you have to close it or you won't know if your data made it onto disk. So let's write a text file. It says, you will be provided with a file path for input I and a file path for output O and a string S and a string T. Read the contents of I, replacing each occurrence of S with T, and write the resulting information to file O. You should replace O if it already exists. So we're going to have a file. We're going to do what? We're going to open file I for reading. We're going to open file O for writing. Okay. We're going to read in the data from I, file I, and then replace data, replace content of data, and then write data to file O and close files. Okay? So does that sound reasonable? Okay, I'm going to assume it sounds reasonable. Okay.
Sounds pretty
So
good.
the first, all right, so I'm going to have file I equals open. And I'm going to do I for reading. And then I'm going to have file O, open, O for writing. And then I'm going to read in my data equals file I dot read. Whoops. I have to type tonight. I dot read. And then we're going to replace data. And then we're going to write it. So we're going to set file O dot write data for now. And we're going to have file I dot close and file O dot close. So let's just check it for a second. All right, it's not right. We know that it's not right, but we also know right now that there are no syntax errors. So, which is good. So we've opened the file. We got output because here it is. It got it from the file, but it wasn't the right output, which is fine. So now I'm going to go and ask Google, so how to replace strings in Python. Append. Okay. String dot replace. Okay? And again, I'm going through this because I want you guys to see how it's done. All right? So what we're going to do is we're going to say not replaced. How about that? Data dot replace. Oh, wait a minute.
String dot replace.
Replace data. And what are we replacing? We're replacing. We are replacing each occurrence of S with T. Replace S, T. Let's see if this works. No, error name string. So it's not string, it's going to be data. Let me go back and look at that. I don't think that's right. String replace. That was one I just looked at, wasn't it? Okay. There we go. Hello world dot replace. Okay. So this is Python. The syntax was not quite right on the first site that I went to, and that's okay. It's thinking. Gee, I hope Codio is not going to do something weird and start giving me errors. Okay. Hold on. Let me see if I can reset this guy. Okay. That was the old one. Check it. All right. The program didn't output right. That's why. Oh, replace. I had replaced equal data, and then I didn't write out the right thing to my file. So that was wrong. Whoops. Sorry, I've been working way too many hours these days. Okay, so when I ran it that time, it was right. So that's pretty much how you read in, replace data, and write out. So data can be formatted. What's the important part of data formatting? Well, there's all kinds of things that go along with data formatting. A .docx, a .txt, a .mp3, all denote the kind of thing that's in the file. And that's good visually, and it's also good from a programmatic standpoint, because a lot of computers, a lot of operating systems like Microsoft, know how to open a file when you double click it, because it recognizes the extension of the file. So you'll double click a .docx file and it'll open it in Word. And that's because it recognizes the extension as a Microsoft Office extension. You'll be able to double click an MP3 and have it play a song or some form of audio. So file formats are important for one reason, so the operating system can recognize them, and also so that we know what we're doing with a file, okay? There's more than just extension. There's magic numbers and MIME types. And you're not going to have to worry too much about magic numbers and MIME types in this class, but we should introduce you to the topic, okay? A magic number it's the first 2 bytes in a file, and it tells us what the type of the file is. So that if somebody has changed the extension of a file, you can look at those very first 2 bytes and know whether or not a program can know whether or not it's opening it up. So if you change a .mp3 and you change its extension to .docx and you double click that, Microsoft is going to say, hold on, this isn't the right file type. I can't do anything with it. And it's going to give you an error. Well, it knows that because of the magic numbers in the file. And then further, above that is the MIME type, okay? MIME types are extensions and are used by mail systems and HTTP and other protocols to know what file is coming over the wire. Hello, come on. What's Cody doing? Waiting for, okay. So fixed length records. And I don't like this particular challenge because most people don't use fixed length records anymore. You will find fixed length records in satellite imagery and a few other things, but you don't find a lot of fixed length records anymore. So what fixed length records do is they say that from character 0 to character 10 is going to be the first name. From character 11 to character 25 is going to be the last name. And from character 26 to character 37 is going to be the telephone number. So basically what you do is you have a fixed length for your data, and that's all that can fit into it. And there's no delimiters. There's no way visibly to understand what the data is other than knowing where these cut off. So you could have data that runs together and becomes completely unreadable from a human standpoint. But if we look at the code here, what we have is we have our data, okay? Our data is fixed lengths, and we have some number here, some number here, some number here, and some number here. And this will be the first field, and this, I think, is the second one, or maybe this is the second one. Yeah, and then this is the third one, and this is the fourth one. So there are 4 fields of data. I'm sorry, it says record length 6. So there's actually 6 records here. And what they want to do is they want to use a substring, and they want to, instead of having this long string of data, they want to turn it into an array. So we use a while loop, and we have a record length. The record length is 6 characters. So each record will be 6 characters. And we go from the data, start, the start plus length. So this syntax here is new, and what it does is it says from wherever my start is, 0, the start plus record length, so that would be 6, so 0 to 6. I'm going to then append that part of data to an array element in my records array. And then I'm going to add the start and the record length, and it's going to go start again. And then we're going to just print them out. That's all we're doing here. This is something we've done before. But this is the new syntax here. And what that basically just says is from this point in the string to this point in the string. And it's not inclusive. So this will be starting at 0, and then since it's 6, it'll be 0, 1, 2, 3, 4, 5. Now there's also a handy-dandy little function called the strip function. And the strip function basically gets rid of trailing and preceding spaces. If you don't want the spaces there, they don't have to be there. So this is just a split test. So we're going to do a fixed length record example. You're going to be passed in a file name P, and that's going to have a first name, a last name, and a birthday. Load the fixed length record, file P, search for F and L in the first, and change the birthday B, then say to B and save the file. Okay, so we have file P with first name, last name, and birthday. And so this one's a little bit complicated, and I'm not thrilled with the description. So I'm just going to start here because sometimes it's easier to start by copying. So the first thing I'm going to do is I'm going to open P, okay? So my file is going to be open P for reading because I don't need to write to it. And then I'm going to read in data equals file.read. And then I'm just going to leave that print data here. Now we don't know how long the record lengths are. And that's one of the things that irritates me about this because we don't know. So we're going to search for a record file in P, given the first name and the last name, and then change the date of the birthday. So what we're going to do is we're going to do a search. Not going to need this, not going to need that. We're going to, okay, well, I'm going to go back and look at our challenge where we did the search. Okay, so I did a data replace here. See if that's helpful. And there's also going to be a search. Okay, so you know we're going to have to replace the birthday. Okay, and I don't think I'm going to need these loops. So we want it for just the first name and the last name. So I'm going to say if, and then save the file. Okay. So I have to open it for reading and for writing. So I'm going to say, now let's do this. Let's just see what happens when we print it out. Okay? All right. So what did it have a problem with? Oh, P is not defined. That is true because capital P is not the same as lowercase p. Okay. Exactly one of read or write. Okay. So we're going to read it first and then write. Sorry, I was thinking Java there for a minute. All right. So what I've done here is I've just looked up what it is. So failed for input, Adam Smithers, and that. And it wanted us to output, or it said we should output that. So basically what they want us to do is for Adam Smithers, they want us to replace Adam Smithers' birthday with that. So what I have to do is I have to find Adam Smithers and then replace the birthday directly after Adam Smithers. And we know that it's what? 1, 2, 3, 4, 5, 6, 7, 8. So we know that it's an 8-character birthday. So the first thing I want to do is I want to find where Adam Smithers is. Okay? So I need to find the place where Adam, what do I want to do? I want to find the place where Adam Smithers is in, oh, we got to get going. I'm sorry. I'm going to leave you guys here because we haven't even started regular expressions yet. Okay? So, and we can work on this one a little later. If you have questions, email me. So, variable length records are easier than fixed length records because they're delimited. A delimiter is basically something that separates it. Everyone has seen comma delimited. You've seen a CSV, comma separated value file. You can save any Excel spreadsheet out to CSV. It just has commas. That comma is a delimiter. Okay, and the delimiter just basically says, here's the separation point. So I don't have to worry that the record length is fixed. I know that when I hit a comma, or when I hit the pipe symbol, or when I hit a colon, depending on what the delimiter is, I've hit the end of that piece of data. And there are some interesting things you can do when you have delimited data. You can join it and make it so you can split it, which splits it into a list. So you have this thing split here, and that will put it into an array. You have join, which will take the array and put it back into a delimited list. So Python makes that very, very easy. So if I run the code to the left, you'll see it's ABC. That's what the delimiter did. So we started out with a list, the delimiter was a colon, and we did a join. And what happened when we did the join is we got a string out with A colon B colon C. Split does the opposite. I can have a text, a string that's A colon B colon C colon D. And I can tell it that the delimiter is a colon, and when I split text with the delimiter, I get a list. So delimited strings are much easier. And just like, in the sample program, they just have a couple of functions. They aren't necessary, but they have them, I think, just to reinforce the whole function thing. So here we have the same output that we had previously, except we got it it's a much simpler thing. There aren't a lot of for loops going on. There aren't a lot of while loops going on. The data is delimited, and we can use split to put it into a list and join to put it back into a string. So variable length records, in this case, we're just going to have a pipe delimited for first name, last name, and birthday. And load array means that we're going to do a split, and then make text from array means we're going to do a join. And they just want us to call all these functions. So the file path, what we're going to do is we're going to open the file for reading, and then we're going to read the data in, and then we're going to data equals file.read, and now we're going to say we'll just call it record list equals data.split. And what's the delimiter? Did they tell us what the delimiter is? P. The pipe delimiter is P. Okay, and we're going to return record list. Okay? So find index, we're going to return have our records. So this is our array, and we have the first name and the last name, and we want to know what the index is. So I'm going to say for in records, we're going to say I'm going to leave this out because I don't know what record looks like yet. We're just going to do that right now. And I'm going to run it, and it's going to give me some errors, and that's okay. Indentation error, 38. What did I do wrong on 38? Oh, that's what I did wrong on 38. So before I do this, I'm going to print record list, because I don't know what record list is supposed to look like. And one of the reasons I'm doing this for you guys right now is because I think the program doesn't give us what we need. Indentation error on 39. Oh, that's true. We're just going to say print here, just for now, so we don't get the indentation errors. Okay. So here we have Adam Smith. All right. So now we know what the records look like. Okay. So we're going to have, why didn't that delimit? Okay. I see what's going on. Okay. Your program output okay. So really it's not, it's delimited twice. There are new lines and then there are pipes. So I print record list. P is P, sorry, load the pipe delimited file P. Okay, so that's P. And so I'm sorry, this is going to be the pipe. Now let's check it. I didn't read that right. Okay, this is better. Almost better. 1, 2, 3. Okay. So this is still not right, unfortunately. I'm going to, because we're running short of time, I'm going to leave this one, but I'm going to put up some information about it in the class a little later on in the week, but we still have to get to regular expressions tonight. And as it is, we'll probably be here till 10:30. So this isn't right. It really, I think I need to read it in by line. So does that work for everybody? I'll put up information about this one and about the previous one in the class this week. I'll try and do a little video about it and put it up in the class so you guys can see what's going on.
Video would be great. Thank you.
Okay, I'll do my best. I'm still slammed at work, but I will do my best. And we'll also talk about the final challenge in those videos. So we're done with this one, but I promise I will go back and try and put up some videos about those. So the last module in the class is regular expressions. And the regular expressions is what our final milestone is going to be about. And that's why I wanted to try and get to it tonight. Now, you saw in the previous examples where I was doing like a replace and a search. Well, that's pretty much what regular expressions is, but they do it really, really, really fast. And there's this given syntax. So regular expressions are like a language within a language. Sorry, I need to get something to drink. Hold on. So regular expression has a pattern, and the pattern is what you're trying to match to the string. And a pattern is just that. It is just a way of describing to Python what a series of characters may look like without actually having to have all of those characters. So you have wildcards. So you could use a star. It says anything between this character and this character, anything between an A and a D, but never a Z. You can say things like that. So regular expressions are very, very powerful, and they are a language within a language. It is used oftentimes for substitutions. And what you'll see here on the left-hand side is an example of the regular expression. First of all, we import something new. If you're using regular expressions, you always have to import RE. RE is the regular expression module. Now, you're going to have a string that you want to search through. Okay? That string can be a book. That string can be a sentence, but it will always be a string. You'll always use regular expressions with strings. And then you're going to write a pattern. A pattern is just what do I want to find so that I can replace it? And that's really what you're doing in regular expressions. You're trying to find things and replace it. So an example of that would be, let's say I had a very long document, a long text file, and I needed to pull out everything that looked like a Social Security number from that long text file. Well, I don't want to sit there and read through that long text file for something that looks like 3 characters dash 2 characters dash 4 characters, or better yet, 3 numbers dash 2 numbers dash 4 numbers. I want to write a quick Python script to find all of those things. So I would write a pattern, and that pattern would say from 0 to 9 3 times, followed by a dash, anything from 0 to 9 2 times, followed by a dash, and anything from 0 to 9 4 times. And that would be my pattern. And I could go and I could pull out as many things that match that as there were in the document. So when I talk about having a pattern, that's what I'm talking about. And what you can do is you have a pattern. You will have a substitution. So let's say I wanted to change all of the Social Security numbers to just say capital SSN rather than actually have the number in it. I don't want the number for security reasons. I just want the capital letters SSN. So I could have a substitution, and then I would use the sub function provided from the RE module and do a substitution. I would tell it what pattern, what substitution string, and the original string I wanted to search through. So that is what we talk about for regular expressions. Now that's really, really quick, but that leads us into our final project for the class. And this is all about regular expressions. So what we have here on the left-hand side is we have these massive texts. We have the original text, we have the Laura Ipsum text. Laura Ipsum is just something that generates a bunch of Latin sentences. And what I want to do is I want to find some things, and I want to replace some things. So if I look at completing your project, it says remove all extra comments. Okay, don't worry about that. So let's not worry about that. So are they telling you what you should do, or is it just in the thing? Okay. That's just the submission stuff. Okay. I want to see here. What happens if I just uncomment this? There's not even anything to let you run this. Well, at least it tells you how to download it. Okay. Run current. All right. So it looks like all you have to do with this one is uncomment those. So just uncomment the lines that were commented out. And it looks like it'll run just fine. And then download it and upload it. Sorry about that. That's weird. That's different than last semester. So just take those lines that were commented out and uncomment them, and then upload it. That's all you have to do.
My version doesn't have all that stuff that you're uncommenting out. Like, I don't think if you go back farther, it'll take you back to the beginning more. You're not in the beginning.
Ah, sorry about that. My bad. Okay. Okay, I apologize. Okay, let's start again. Okay, so first thing we're going to do is we're going to determine the number of non-alphanumeric characters in the Laura Ipsum string. So non-alphanumeric characters are commas, colons, dashes, periods. Those are non-alphanumeric characters. So it's not in the alphabet, and it's not a number. The second thing we're going to do is we're going to replace all instances of the word sit with the word emet. Oh, sorry. The word sit and the word emet separated by a dash or colon with a space. Let's go see what those mean. Okay. So we have these two things. We have original text and Laura Ipsum. So these are the things we're going to be working with to change. First thing I have to do is I have to find all well, the first thing I have to do is I have to import the RE module. That's what it says here. And then they're providing you with the original text and the Laura Ipsum text. And you're going to be changing the stuff in Laura Ipsum. We're going to find the instances of non-alphanumeric characters in the string assigned to Laura Ipsum. And we're going to use the regular expression operator. Okay. So I don't think I was at the beginning of the regular expression stuff either. Okay, I'm going to go back and I'm going to apologize because I wasn't in the right place. Let's start this again. Regular expressions. We're going to start at the beginning. I apologize to everybody out there. I apologize to everybody online. What are regular expressions? Okay. Now we got it. I must have been going through this and forgot to put it back to the beginning. So I apologize for that. Okay. So what's a regular expression? A regular expression is just a pattern that is kind of like a language inside of Python, and it is used for string matches and replacing. So the regular expression is a language, and there are two types of characters in the regular expression language. You have meta characters and everything else, and it's that simple, okay? Down here are the meta characters. Meta characters have special meaning in Python, and so a star isn't just a character in the regular expression language. It has meaning. A dot has meaning. Now, there are ways you can make them act like regular characters, but they're special without escaping them. And here is the full set of meta characters. Here's the link to it. So we have, go ahead. Okay. We have, this is just a rundown of the types of meta characters that are used most of the time. So a dot is, it will match anything except a new line. The caret says at the start of the line. The $sign says at the end of the line. Star is 0 or more repetitions. So X, Y star will match X, Y, X, Y, 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 and will also match X because it's 0 or more repetitions. Plus is 1 or more. So plus will match, X, Y plus as a pattern will match X, Y, X, Y, 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 but not X. Question is 1 or more repetitions of the whole regular expression. So XY question will match X and XY. And then there's greedy and non-greedy. And then there is matching something exactly. So A, curly bracket, 3, uncurly bracket, will match AAA. So it'll match 3 A's, but it won't match 2, 1, or 4. And you have curly bracket M and N, so exactly M through N copies. So A, B, 2, 4. So that would match 2 A's and a B, 3 A's and a B, 4 A's and a B. But it won't match a single A and a B, an A, or it won't match 5 A's and a B. So this means A, I want it to be 2 times, 3 times, or 4 times with a B directly preceding it. Okay. This is an escape character for meta characters. So if you want to match a dot, you would put a slash in front of the dot. If you want to match a star in a string, because it's a meta character, you would put a slash before the star and it will match the star character. And then you have set. A set basically says match anything in between these brackets. So open square bracket AB, close square bracket will match A, it will match B, or it will match AB. Okay, so searching. This is where regular expressions become very powerful because they're extremely efficient at searching through code. So what we have is we have this pattern on line 3. That pattern is ABC. So this pattern right here will match A, it'll match B, it'll match C, it'll match AB, it'll match BC, and it'll match ABC, but it won't match AC. So let's see what happens when we run the code. Okay? So we have, it'll match A, okay? Match 1. So A stir is A, so it matched. B stir is B, so it matched. C stir is C, so it matched. AB it matched. BC it matched. ABC it matched, but it did not match XABC because there's no X in the set. A wildcard search. A wildcard search uses the meta character star, and it's matched 0 or more repetitions of the characters directly preceding it. So for the pattern, it's XY star. So it's going to match 0 or more repetitions of some combination of X and Y. So we'll see here that it will match an X, it'll match an XY, and it'll match an X with a lot of Y's after it. Search repetitions. So here we have a pattern which is X and then 10. So it will match X 10 times. Or in this case, on line 3, we have an A 3 times. So what will it match? Will it match AAAB? Will it match AAAA? Will it match it 4 times? Let's see. So it matched this because this string had A in it 3 times. It matched this because it is A 3 times. And it matched this because it had 3 A's in it. It did not match the string with 2 A's, and it did not match the string with 1 A because there weren't enough A's. Okay, so the regular expression challenge. This is, I think, where we were. Write a regular expression that will find all occurrences of regular expression dash, regular expression colon, and regular expression ampersand in the string that you're supposed to search for. So here's the pattern that we have, okay? And that pattern is going to start with the word regular and end with the word expression. And as it's set, it's going to have the open bracket and the closed brackets, which are meta characters. So they're not part of the search. They're just defining part of the search. And in this case, we're going to have a space, a dash, a colon, and an and. So anything within that set, it will match. So this regular expression will match regular space expression, regular dash expression, regular colon expression, and regular and expression. And then what I'm going to do is I'm going to do something called a find all. And what find all does from the RE module is it gives me back a list of things that we have. So if there are 5 occurrences of it, there'll be 5 things in the list. So if I run this, it passed. Okay? So what I have here is I have match 1 equals re.find, and if match 1, I'm sorry, find all doesn't give me, no, it does. So if match 1 is not none, which means the list didn't come back empty. So sorry, the list didn't come back as not defined. Then I'm going to print match with results. If not, I'm going to print does not match. So in this case, I printed match with results. Okay, so now we get to replacing. Replacing is important as well. Okay, and this is one of the things that, like I said in the Social Security example, that it can be very useful. Okay, so I want to replace my space val dash underscore equal or at. We want them all to be my dash val. Okay? I think that's a single dash. So what I'm going to do is I'm going to write a Python pattern. Here's my Python pattern. Starts with the word my, end with the words val, and then it has a set, flanked by the meta characters, open bracket, close bracket. And it's anything with space, dash, underscore, equal, or at. So, sorry, here's my pattern. Oh, and it's a double dash. That's what I want to replace it with. My substitution is my dash dash val. So what I'm going to do is I'm just going to print out my sentence, which is here. This is the thing I'm going to be searching through. And then I'm going to match it. And then I'm going to say, you know, match is whatever it is. And then I want to replace the results. So the replace is not, the replace function is called sub. So it's from the RE module. I have a pattern, which is this pattern. I have my substitution, which is this substitution, and I have my sentence. And that's what's going to be replaced in. And that will show up as replace results. And then replace, I'm just going to print out replace results. And I'm going to check it. And yeah, I already did these. So my apologies for not going through them with you. Okay, so this one looks very similar to the last one. Okay, so this is basically the same thing we saw before. We're going to replace these with regular space expression. So instead of just finding them this time, we're going to replace them. So in the previous one where we had regular expression, we just found them. This time we're going and we're going to do a sub on them. And we're going to replace everything. And when we check it, this one comes out fine. So that's the basic difference. We still have our pattern. You always have your pattern. When we're substituting, we have a substitution string. We have our search string. And notice again, these are all strings. And replace results is we're going to substitute. We're going to use the pattern and the substitution string and then modify the search string. My apologies, sorry. Okay. So now, back to the regular expression draft. I apologize for not being in the right place. Okay. So what we're going to do is we're going to find and print the number of non-alphanumeric characters in the Laura Ipsum string. Sorry. So we have an original string and a Laura Ipsum string. And the output should be 144. Now, what do we do here? Well, what we're going to do is we're going to have a pattern. And in this case, we're just putting the pattern in as a string. Sorry? Okay. And here we have our set. And our set is flanked by the meta characters, open square bracket and close square bracket. And I'm sorry if you hear something weird in the background, it's my dog coughing. And it's everything that is not A through Z and capital A through capital Z. And this should come out with a result of 144. So if I check it, oh, I have too much in here. So it did come out with 144. That's why. Okay, now I know what's going on. Okay. Okay, so this one passed. So this is just using the find all function, and that's really what the purpose of this portion of the challenge is for. How do we find all instances of something and get a number back? So find all is going to give me the number of times that a non-alphanumeric character showed up in Laura Ipsum. Now we want to find and print the number of set and emit separated by some punctuation mark. So it could be a dash or it could be a colon is what we're seeing here, and we're going to use the find all method to do it. So first of all, we're going to do a find all, and we have sit, emit, and then we have our open and close brackets. Our open and close brackets are going to have our set of a dash or a colon, and we're going to determine how many of those are in the Laura Ipsum string. And we're going to print those out. So when I check it, it says 3. And I'm not going to worry about this extra 144 there because it's just from the previous one. So now what I want to do is I want to replace set and emit words separated by punctuation marks with a space. So anytime I have sit dash emit or sit colon emit, I want to make it sit space emit. So here I'm going to use the sub function, which is what we used previously, and I'm going to get the number of instances, and I'm going to replace the result, and then I'm going to make sure that the number of instances is right. So here I have a sub, and I have my set colon dash emit, and I'm going to replace it with set emit, and I'm going to replace it in the Laura Ipsum. And it was just expecting 3, but don't let this worry you when you do it, because you can comment those out if you want. Okay? So that's what this challenge was about. It was just about learning how to do regular expressions. And so what you're going to do is you're just going to follow the remainder of these And with the milestones I checked, you do, because we have to grade to the rubric, you do have to download them and then upload them to the to Brightspace. So does anyone have any questions? I know we went really long tonight. And I know it was a lot of new information.
No questions right now. Thanks.
Okay. So I hope everyone has a good evening. Please email me, and I will try and put up some stuff this week about those file examples, okay?
Okay, thank you.
All right. Have a good evening, everyone.
You too. Good night.
Thank you.